Okay, welcome back. We are in module 3, and this is Engage New York, module 3, lesson 7. This is concept development / problem set. So we're going through the problem set together. We're working out these problems. We're drawing it out and coming up with different methods on how to solve these problems, because not everyone's brain works the same way, and everyone needs to find what works best for them. How do they solve the problem? How do they picture it, and how do you gather the information and to make this work for them? All right, here we go. So George weeded 1/5 of the garden, and Summer weeded some too. When they were finished, 2/3 of the garden still needed to be weeded. What fraction of the garden did Summer weed? All right, so we're going to start off with drawing the garden. So let's just start off drawing the garden. I'm going to start way over here, give myself more room. All right, so 1/5 of the garden. So we have George equals 1/5, and Summer weeded some too. All right, so then we have an unknown, and Summer weeded some too. Oh wait, I'm going to change the way I wrote that. I'm going to write Summer question mark. I'm going to write Summer question mark. We don't know how much she weeded, but what we do know is when they were finished, 2/3 of the garden still needed to be weeded. So at the end, 2/3 still needed to be gardened. Okay. Or weeded. What fraction of the garden did Summer weed? So that's what we don't know. So what we're going to do is we are going to break this garden up. Now, we know that we have 1/5 and we have 2/3, right? These are our two fractions we're working with, correct? All right, so I wonder if we scoreboarded, could we find the common denominator in order to cut up the garden? So if we were to scoreboard 5 and 3, 1, 2, 3, 4, 5, 5, 10, 15, 20, 25, 3, 6, 9, 12, 15. Oh, there it is. 15, right? Okay, so let's take 1/5. We're going to take 1/5 times 3 plus 2/3 times 5. And we're going to get 3/15 plus 10/15. That's how much 2/3 of it still needed to be gardened. So now we're trying to figure this out. Okay, so 13/15 now is our total number here. So let's come back up here and let's section this off. Let's do 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Let's cut it into thirds. And now let's put this into perspective here. All right. So George is 1/5 and 1/5 is 3/15, right? So here's George, 3/15, right? Now, we don't know how much summer garden, but we do know that 10/15 was still left over. So let's color in 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10/15 was left over. So how much did Summer garden? How much did she weed? She weeded 2/15, right? 2/15 is equal to Summer weeding. So do you see how drawing the picture just helped us solve that so easily? All right, so let's try another method. So let's take, so our method, here's method 1, right? We came in, we didn't know what Summer had garden. We did know what George had garden. We knew what still needed to be garden, and we added them up. And we knew there had to be 15 all together. 15 pieces all together because we scoreboarded and found a common denominator. Added it up, got 13/15. Well, 13/15, 15 over 15 minus 13 over 15 is going to give you 2/15. All right. And that's exactly what we did up here. So let's go to method 2. So let's go. Now, I could have done, before I move on, I could have gone now 15 over 15, which is the whole lot. Subtract 13 over 15, and you're going to get 2/15, which that's exactly what we got when we drew our picture. All right, method 2, though. Method 2, so do you see why I gave you a lot of room to work here? Method 2. Let's say method 1. Now, I do have to say, a problem like this, I would think you would see on the SBA, that standardized test that we take at the end of the year. A problem like this would so be common. This would be a common word problem that you would see on that test. All right, so let's go to method 2. So method 2, I'm going to start with 1 whole. So we know that George weeded 1/5 of it, and I'm going to start with 1 whole, and I'm going to subtract 1/5. Well, can I subtract these the way it is? No, because they're not like units. So I have to change this to 5 over 5, and now I can subtract, right? So that would give me 4/5. Now, we know that 2/3 was left over, right? So let's take 4/5 and subtract 2/3 from it. Now, we need to scoreboard again, but we already know what our common denominators are going to be. So we're going to multiply this by 3, multiply this by 5. We're going to end up with 12/15, subtract 10/15, and what does that give us? 2/15. That is Summer's contribution. Summer's weeding. Okay, so I just showed you 2 different ways to solve this problem. 1, I brought the 2 numbers that we did know, put them together, scoreboarded, found the common denominator. I found out how much space was taken up altogether. Then I took 1 whole, subtracted 13/15, and got 2/15. That's the answer. That was the area we were looking for. And then in method 2, 1 whole, subtract the 1/5 that we did know. And then we got 4/5. And then I took my 4/5 of what we did know and subtracted 2/3, what we also knew. Got 12/15 minus 10/15 is 2/15. All right, method 1, method 2. Which way speaks to you more? Which way did you understand the problem better? That's the big idea. This is a problem that you are going to see again and again and again. And I have a feeling a problem very similar like this will end up being on that end of the year test. So understanding how to work this problem, when you get these problems, being able to read the word problem, pull out the information you do know, and try putting it together. Always draw a picture. Drawing the picture basically told us exactly the information that we needed to know. All right, moving on. Problem 2. All right. Jing spent 1/3 of her money on a pack of pens, 1/2 of her money on a pack of markers, and 1/8 of her money on a pack of pencils. What fraction of her money is left? Well, always start out by drawing some sort of tape diagram or some picture. All right, so I'm going to draw out my tape diagram. All right, so she spent half of her money on pens, half of her money on a pack of, half of her money on a pack of markers. So that's half. Then she spent 1/3 of her money on pens and 1/8, which is going to be small, on pencils. What fraction of her money does she have left? Right? All right. So what could we do? Well, how about if we start with 1 whole? This is how much money she starts with, right? This is the money that she goes to the store with. And let's take away 1/3 of her money. Then we have to take away half of her money, and then we have to take away 1/8 of her money. Okay? So what do we know? Can we subtract these two numbers just the way they are? No, we can't. You're right. We have to change this 1 whole into a like unit, right? So we're going to change this to 3/3, subtract 1/3, subtract 1/2, subtract 1/8. All right, well, let's keep going. So 3 subtract 1 is 2/3. So notice I'm just doing this a little bit at a time. Now, how about if we just subtract? What if we solve for these and we subtract in between? All right, so do you need a scoreboard or can you tell what the common denominator would be here? Hopefully you said, I can see that that the common denominator could be 8. So this would be 1 times 4 is 4, right, over 8. Subtract 1/8. So 2/3 subtract 4 subtract 1 is 3/8. All right. All right, so what should we do next? Can we solve these two subtractions the way they are? Think about it for a minute. All right, you guys, hopefully you came up with the answer. No, you cannot subtract these because they are not like units. We have to remember, take these two fractions that are on two separate number lines, and we have to move them, pick them up, and put them on a new number line that they both share. That's called creating an equivalent fraction, right? That's what we've been doing. That's been the big idea so far in this unit, in this module. So 3 and 8. So hopefully you're seeing 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. Oh, look, there it is. So let's multiply this one by 8 because 3 times 8 is 24 and 8 times 3 is 24. All right, so now we